You are tuned in to the FowlWeather podcast, the forecast to your next successful hunt. Coming to you from the home office, Jack's Reef, New York.
I'm Dr. Mike Schumer with the FowlWeather podcast. Today I'm going to break down how we make our weekly duck migration forecasts. In a follow-up video, I'll go into detail about how we use global weather forecasts and conditions to develop our seasonal long-term forecast. Remember to follow us on Spotify or Apple Podcasts to get the most up-to-date information from the FowlWeather podcast. The forecast we produce uses the most up-to-date science about weather factors affecting duck migration. We've compiled decades of research to bring you these weekly forecasts. A variety of weather factors were tested using waterfowl survey data from areas throughout the Central, Mississippi, and Atlantic flyways. Basically, waterfowl survey data were paired with nearby weather station data, and the best predictors of increases or decreases in ducks at any one location were determined. This information produces an algorithm or mathematical model that can predict relative increases or decreases in the numbers of mallards, black ducks, pintails, widgeon, gadwall, green-winged teal, and shovelers. So the research that is used to predict weekly duck migration originated in around 2010, was verified and approved upon in 2016, and continues to be refined to this day with the best science available. The best predictor of duck migration for all species was a combination of temperature and snow, which, when we combine those all together, produce what's called a Weather Severity Index, or WSI. I'll often refer to this metric as WSI through this video and on the FowlWeather podcast. Right, so this makes sense. As duck hunters, this is pretty common knowledge, because the colder it is on any given day, the more energy a duck directly spends just trying to stay warm. The snow depth on that day, the WSI is calculated directly. That amount of snow on the ground directly interferes with field-feeding ducks like mallards, black ducks, and pintails that can often stay farther north than some of these other species by feeding on energy-dense waste grain or grain left in fields following harvest. The numbers of days in a row that the temperature is below freezing has cumulative effects on duck energy budgets and affects wetland icing. That is, many cold days in a row result in greater energy expenditure by ducks, while also making it harder for them to obtain food because wetland availability is decreasing because of wetland icing. A lot of these shallow edges where these ducks can actually feed are disappearing, and so food availability is declining while energy expenditure is increasing. Lastly, the numbers of days in a row with measurable snow on the ground affects energy input from those field-feeding ducks as well. So the WSI that best predicts duck migration is 1, how cold is it? 2, how much snow is on the ground? 3, how many days in a row has it been below freezing? And 4, how many days in a row has there been measurable snow on the ground? These metrics add together to provide the WSI. Now there's one trick in here. You have to switch the sign of the daily temperature so that below freezing temperatures produce a positive value to be added to snow depth and days below freezing with snow. Now let's look at what this looks like on paper. Don't let the figure confuse you. I'll walk you through all of these dots and lines. The up-down line, or the y-axis, tells us if ducks are increasing or decreasing. So that above the left-right line, or x-axis, we have increasing numbers of ducks. Dots higher up the figure are greater increases in the numbers of birds in an area. Now the dots below the x-axis are decreasing numbers of ducks. And again, the farther down the y-axis, the greater the decrease in ducks. The right to left axis, or x-axis, is the WSI value, so that the farther to the right we go, the more severe the weather. And noticeably, the dots are increasingly below the x-axis and farther down the y-axis, indicating substantial movements of ducks out of an area, and presumably to locations farther south. Now, an important piece of information is that where the y and the x-axis meet is a WSI of 0, or 0 degrees Celsius. So this is the break point between when average daily temperatures are right at freezing. Points to the left of the y-axis along the x-axis are above freezing temperatures. So if you look closely at the average trend line of the WSI, or that solid line that curves through the middle, goes through all the dots, you'll actually see that ducks, and in this case this is mallards, actually increase for quite a while, even after the average daily temperature is below freezing. So for a big duck like a mallard that exploits or uses a lot of different habitats and foods, they can sustain at northern latitudes much longer than other species like green-winged teal, which is the smallest dabbling duck in North America. So that threshold of when we estimate ducks start to decrease at a location, or on this figure, where that trend line crosses the x-axis, that's represented by that red dot. The FowlWeather analytical team computes WSI values by pulling 7-day weather forecast data from NOAA at key locations across the Central, Mississippi, and Atlantic flyways each week. Using our WSI algorithms, we determine to what extent ducks are forecast to be showing up in your area, migrating out of your area, or staying relatively the same in abundance. That is, we can predict the grand passage of ducks before it happens and provide you the best days of the week to go hunting. On the FowlWeather podcast that drops every Sunday night, we interpret data outputs that predict likelihood of duck migration, but we also include other information such as river flooding, timing of grain harvest, and other factors that as duck hunters ourselves, we know influence duck migration southward each fall and winter hunting season. To be clear, the science of duck migration is not an opinion. I may provide some commentary here and there about a variety of issues affecting waterfowl conservation and hunting, but the science behind our forecast is solid and useful to inform you about the best days to hunt throughout October to January. So think of it this way. If I'm right 75% of the time, but you typically have a 50-50 chance of picking a good day to hunt, you should probably follow this page and the FowlWeather podcast, because the math says you'll improve your chances by 25% at minimum. Remember to follow us on Spotify or Apple Podcasts to get the weekly updates on migration from the FowlWeather podcast.